Okay, so we're having an object that's projected at an angle of 30 degrees. So here's it's thrown up at 30 degrees here, and we'll call it like some value p. And so I know that my initial velocity has an x component and a y component here. My x component, well, x over p is equal to cosine, so this is actually equal to p cosine 30, and this will actually be equal to p sine of 30 as my initial velocity. So my velocity initial, I'll call it, of t, is equal, or maybe I could just velocity at 0. Yeah, that's good. Velocity at 0 is equal to p cosine 30, p sine of 30. And so I'm actually asked for the initial speed, and I hit the ground again at 6 seconds. If it hits the ground, that is going to be my r of t. And if I can find r at t at 6 seconds, I know it's going to hit the ground. That is going to equal to 0 for the y value. So I have to build my function and get my displacement. In order to build it, I'm going to start with acceleration. And I know acceleration is always 0 and negative 9.8, because that's gravity. Finding velocity then is just going to be the integral of acceleration. Well, that's going to be c1, some constant, and this is going to be negative 9.8t plus some c2. I know my initial velocity, though, at 0 are these values. So if I make t 0, I end up with these. So that means my velocity function I can write as p cosine of 30 negative 9.8t plus p sine of 30. And then going further, because I know when it hits the ground that's displacement, I'm going to go further and find my displacement vector. And so I get pt cosine of 30 when I integrate this, and negative 4.9t squared, I've done this integration many times, plus pt sine of 30, plus a constant c4, we'll call it, plus a constant c3. Here is my x, my y value. But I also know the initial position when t equals 0 is 0, 0. And so again, if I plug 0 in for t, that's 0, and so c3 is equal to 0. I can just get rid of it. If the t is 0, this is 0, and this is 0, and it equals 0, so again, I can get rid of c4, and this is my displacement function. I want to know when it hits the ground again at 6 seconds. That means it comes back here and it goes here. My y value is 0 when t is equal to 6. So my y value is 0 when t is equal to 6. So 0 is equal to negative 4.9 times 6 squared plus p and 6 sine of 30. And so p will be the 4.9 times 6 squared over 6 sine of 30. And when I do that, I end up with 58.8 meters per second.